Similarity theorems, chapter 7, worksheet 4. Let's talk about some special circumstances that you want to make sure you understand are also similar. So, one is called the side splitter theorem. You do not need to remember the name of this theorem. You just need to understand what it looks like and what it does. Basically, it says if a line is parallel to a side of a triangle, okay, or just parallel lines in general, it intersects the other two sides and cuts them proportionally. So what that means is BX is going to go to XA as BY goes to YC. So let's go over that. Find the length of each segment. So they're looking for RQ, so that's my X. So with this side splitter theorem, that would mean 12 over X, so part over part equals 6 over 7, the other part over the part. Okay, and you get 14 when you solve for that. Again, over here, JN, so 16 over X, and I'm doing it a different way here just to show you. I can do top part, top, or, you know, whatever you want to call it. I would call this top and top because I see this is the top of the triangle, but you don't have to call it that. But basically, you can do the parts that are across from each other. So 16 over X, 20 over 38. So here I went this way with my proportion. Here I went across. They're both correct. And you get 30.4 in that case. So that's the basics. They could also ask you basically the same exact question, but show that they're parallel. So if you had something like this, all you would need to do is show me that the sides are proportional. So you could set up 15 over 45 equals 6 over 18. Simplify, you get a third and a third, or you could cross multiply and get the same number. And you would say, you have to state this, they are parallel because they divide the segments proportionally. Be careful of the bottom. Highlight this example, whatever you want to do, but you have to be careful of this for the following reason. The side splitter theorem talks about the sides that are cut by the proportional lines, the parallel sides, excuse me. Notice DE in this case is a parallel side. So this is why I say the bottom, okay? And again, this could be flipped, but I'm just talking about these as the bottom of the triangle. So if you see triangle ADE and triangle ABC, okay, this is going to be different. This is not 3 over 6 equals 2 over X. No, 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 because of the following. 6 is not a proportional side. 6 is a parallel side. It's the bottom of a triangle. So this is actually a side of a triangle to a side of a triangle. Notice 2 is not the side of a triangle. 2 is this part that was cut proportionally. So this is what it should look like. 3 over 6. So side over side equals 5, this whole thing over X. Again, 3 and 6 are both entire sides, so you need to use the other entire sides. And you get X equals 10. So let's do another example. We're going to label everything they tell me in the word problem. EB is my X. Again, I do not have my parts, right? I'm not doing part to part, part to part. I don't have that. I have a side to a bottom, so I need to do the whole side to the bottom. So it'd be 3 over X and 9, this whole thing over 15. This is a big mistake that people make, so I'm trying to make a big deal when I point it out. The other theorem is the angle bisector theorem. Again, you don't need to remember the name, you just need to know what it looks like. Okay, when an angle is bisected, so AY in this case would be the bisector because these are the two congruent angles, it cuts it proportionally. So what that means is, you have, in this case, 15 over 9 equals 40 over 24, or 40 over 24 equals 5 over 3, because you know it all rounds, but either way, it's proportional. So let's talk about how we would solve. So in this case, I see my angle bisector, so I know that 8 and X are proportional to 12 and X plus 2. It's the rays of the angles, and then the sides across from the angles. So I would set up 8 over 12, and X over X plus 2. Notice the X is touching the 8. That's why the X goes up here with the 8. You cross multiply and solve. Make sure you don't forget to distribute. And you get X equals 4. Over on the right, number 7, again, we have, oh, sorry, and they wanted more here. Always go back and check what they wanted, EF and FG, so you would substitute 4 in. Over here, 40 over 3Y is equal to 16 over y plus 3. Again, you can set it up a couple different ways. I just wanted to show that. And then we cross multiply, do our thing. They want RV and TV, so I substitute those values back in. So those are the angle bisector. Let's do a couple more because this one really throws people off sometimes. So again, I'm going to do the rays of the angle that was bisected, so x plus 1 and x plus 3 and x minus 1, and then the sides across from the angle, which would be 5 and 4. Cross multiply, solve. Make sure you plug it back into what they actually asked for. Okay, over here, again, 21 and 2y minus 4 are the rays, and then 14 and y plus 1 are the sides across. Cross multiply, solve, substitute your values in. That is it. Make sure you know those two theorems and be careful of the bottoms. Have a great day, and I'll see you later.